Sorry. Yeah, for the recording sake, let's get back. So we are talking about the tasks, the job here, workflow. So in the workflow is basically how you orchestrate your tasks, your jobs, right? So first you kind of create modules, or create functionality in units. Basically you take one unit and build a notebook and test it. Then you take another unit, build it and test it. For example, as I was talking earlier, let's say I have 5 different sources. The data is coming in, and then I have to uh, consolidate, transform, enrich, aggregate, and provide the data to BI. That's what we do, right? In any data pipeline, you ingest, transform, aggregate, and keep ready for the consumption on the service layer, either to data science or to BI or whoever wants to consume. So in that, let's say I am getting 5 different sources. If it is a financial institution, you're getting files from different vendors. Okay. But you have to, or estimates from different vendors. Okay. Or the stock prices from different sources, or exchange prices from different sources, currency exchange prices. So you want to get all data from all sources, and then transform, convert to common USD currency, and then figure out an aggregate over the past week, how the rates are fluctuating or whatever, all that data. For example, I'm just taking a scenario. So how do you do that? You don't want to write one notebook where you want to get data from all 5 different sources, correct? Am I making sense?
Yeah.
Yeah. So let's say one vendor is having, say, his data in a SQL server, and you get access, you can get connection, JDBC connection to their server, and then you pull the data. Another vendor is having, say, MySQL, or somebody is having on AWS S3 their data. Somebody is sending you the files onto a Unix server through SFTP. Okay. So then you have to create each module and test it. So let's say I decide to have one notebook for each source to pull the data ingestion, and then write it to the raw layer. So I take one notebook for MySQL, get connection, everything, read, and then write to raw layer. Then another one, then another one. So I have 5 notebooks. After that, I have a say in the silver layer, where I am doing the consolidation and transformation. Okay. Say I want to combine the data which is coming from S3 and which is coming from SFTP. And then I want to combine the data from MySQL and SQL Server, something like that. So let's say I want to do 2 notebooks for consolidation, transformations for different sources that are coming in the raw layer. Then on the gold, let's say I want to have one kind of layer where I want to do aggregate from this. So I have done all of these notebooks, 5, 6, 7 notebooks. Now, how do I make sure they all run as a job? We have all gone through a lot of orchestration tools, right? Somebody may be Uzi. There are most recent latest is what you call Airflow, um, and before that there are like Control M is one of them. So there are so many orchestration tools. Basically, how you schedule and orchestrate your jobs. So how you do that is, okay, I create a task 1 to start with, then I create task 2. So task 2 is dependent on, so this is task 1. My task 1 is a notebook. Okay. So you can also do mix and match of whatever things, tasks, the source type of notebooks that you want to put in, uh, or queries. So type is a notebook, task 1, workspace, and this is where my path is for the notebook. Okay. This is the ingestion task. Now I give the cluster, depends on it. It is not depending on anything. So it is standalone. So let's take task 2. It is a type SQL, and then I have a query here. Okay. So if you go here, you can go and look at what is the ingestion task. What is the notebook, right? So this is my notebook here. So it's just standard, notebook display, some path, write mode, say loans data, account, and all of this. So this is my notebook. Okay. And this is reading the Parquet file, print the schema, and then it's saving as table loans, and then again reading and doing count and whatever. Okay. So this is one notebook. Now the second notebook, here it doesn't make sense. It's not actually dependent, but I'm just saying. So second one is query. So query, let's say I want to read the data from the loans table, and then do a kind of a filter or aggregate, and then write it to another table, for example. So in that case, so this should be dependent only when this is completed. This should refresh, read the data from loans, right? So if this is not complete or this has failed, then there is no point of running this data. Okay. So that's why we put task 2 is dependent on task 1. Okay. So when you go to task 2, in the dependencies, I put task 1. So if you click on task 2, it shows the dependency here. Okay. So this is dependent on, see the blue arrow. So this is dependent on task 1. Now, when I go to task 3, I want both task 1 and task 2 to be successful, complete when task 3 is running. So normally, if you say if it is dependent on task 2, since this is also dependent on task 1, this is automatically it will come only if these two are complete. But there might be some cases where I will say task 2, it's okay if it is successful or not. Or even if an error, I can mark successful on this one. There is nothing to update also. So there are dependencies, right? When I run if dependencies, so there are different things. I might say, okay, even if it has at least one failed, run it. Or even if it is all failed, run it. So something like that, I might at least one succeeded, you run the task. So that is why, based on different criteria where I will see if it succeeds, what you call a success, I might add multiple dependencies. So this is dependent on, so if we see here, this is dependent on both task 1 and task 2. Okay. Say, for example, task 2 is not dependent on task 1. So these are two independent. One is a notebook that is writing. And meanwhile, you can also run a different SQL query, right? So what does this query have? You can go and look at SQL query. So you created a query, select from this baby names. So baby names has nothing to do with the loans table here. Basically, these two are independent. Okay. Now, in that scenario, if task 2 is not dependent on task 1, I will remove this. Now, once I remove this, see how the dependency chart has changed here. Right? See now task 3, is dependent on both task 1 and task 2. So you can see here the lineage. But task 1 and task 2 are independent. So they can run on their own. They can start and run in parallel at the same time on their own. Now here, when I do task 3, what do you mean by task 1 and task 2? Though it is dependent on both, there are different conditions I can put. Run if dependencies all succeed. So run task 3 only if task 1 and task 2 both are complete. Or I can say at least one succeeded. What does this mean?
If one of the tasks.
Yeah. So see here
At
it
least
says,
one.
yeah, it says if at least one succeeded here, right? So which means if task one is complete or task two is complete succeed, then it can run the task three. If one of them fails, it will still run this. But if both fails, then it will not run this. Okay, so these are different conditions based on the requirement and the business use case. You can check. You can orchestrate your job. So that's how the orchestration works, right? So you can add, as I said, dependent libraries, and as you have seen, so this is a notebook, this is a SQL query. Then let's say I will add another notebook, another task. It's a Python script. So I can also add a Python script. Now, this is dependent on task 2 here. Okay. So I will just say task 4. Python script, workspace. So I have to give some path. I don't have any Python scripts here. Let me see if there is something. No. Yeah, but basically, if you have any Python scripts or jar files, whatever, you can still go ahead and add this here. You can run a jar, you can attach a delta live table pipeline also. So you can run a DLT. You have a DLT where you can trigger, right? So that trigger can be here. So once task 2 completes, it can trigger your DLT pipeline to refresh all the tables downstream. See here you can get all your DLT pipelines, which you can attach. So let's say this is the DLT pipeline you can add. Okay. So if you do this, so you can keep building this graph, dependency graph or the orchestration. So the moment you run this job, task 1 and task 2 will start in parallel. Once one of these completes, task 3 will start. If task 2 is successful, then task 4 will start. These two are independent, so they can run independently in parallel. So you can keep adding based on how you want to execute your functionality. Okay.
So, Arun, this is very similar to ADF, right?
Yeah. Sorry. Yeah, exactly. ADF is also, yeah, you can do orchestration. I mean, it's same. Orchestration is same, right? Tools are
Uh,
different. Basically, it's like you can use Apache Airflow, you can use ADF, whatever it is.
yeah.
You can use that. Every tool has the same concept of tasks in the job and dependencies between them and how you manage that, whether sequential or parallel or conditions when to run the next job and all. In certification also you have get couple of questions on these, like if task 3 is dependent on A and B and task C is dependent on whatever. So he'll ask a question like, if this happens, what is the result? What will run, kind of. And when a task or when a job fails, but half of the data, whenever it's run, it may have already committed. So some part may be successful partially. So something you are updating a table, okay. Um, if it is a bad job, either it will pass completely, or if it failed completely, it's a batch update. So nothing will get updated. But if it's a normal sequential, let's say if it has processed, say 100 records and then it failed, so the 100 will still be persisting in the database, even if it fails. So you have to keep that in mind. If it is when it is a failing, is it a batch update or it is a normal? I think I have seen that question. So if it is a batch update, it will fail completely. It will not update or insert any changes to the, it's basically rollback. If it is not a batch update, sequential, then whatever data that is processed, that will still persist It will still stay. When it failed, it fails. After that, it will not be there. Okay.
I have one question.
Yeah.
So it's possible to link existing flows. So for example, we have an ADF flow. Can we link that flow to a new flow in Databricks, or it's like totally not possible? It's separate.
I don't, I haven't seen at least ADF components into the Databricks. So because containers are different, right?
Yeah. Mm.
But I will check on that.
I'll also see that. Because if you have an existing flow, is it like you have to redo the whole thing again in Databricks, or is it something which you can link to? And that was the idea. But yeah,
But ADF, how does so? So ADF will have its own components that is running on Azure, right?
yes. So if
Uh,
you have a Azure Data Lake service,
yes.
so if you have ADLS set up and you under your own subscription, you have Databricks.
Mhm.
Right.
Yeah.
So connectivity should be possible because it's the same subscription.
Yes.
Uh, but yeah, that's what I was saying. If we can link a existing ADF flow to this, where it does some activity and then it continues here based on what we want. This just I was thinking about it, but
No, no, that's fine. Yeah, that's a good question actually. Interoperability. I
yeah.
have seen you can do airflow
Okay.
with this. If that is possible, maybe
It- yeah.
that is, should also be possible. Um,
I'll also check into that.
Trigger type. Uh,
Is it possible to run these workflows via API?
yes, you can
Yeah.
definitely. So there are APIs for to create a pipeline. There are APIs to run the pipelines, to trigger the workflows. So there are a lot of APIs. Yes, for most of it they have the SDK to trigger these from the external source.
Oh, okay. Then to answer Anush's question, maybe APIs could be an answer where
Yeah,
you can also kick off ADF and depending on that, you can kick off this one
figure, yeah, call
via
thing.
automation.
Yeah.
You see here, you can manage workflows through Databricks CLI, asset bundles. See, yeah, Databricks has tools and APIs that
Yeah.
allow you to schedule and orchestrate your workflows programmatically.
There's a jobs REST API
REST
at the
API, yeah.
Jobs REST API.
that
Yes.
will help for sure.
Yeah. Now see here, you can use Apache Airflow to manage and schedule your data workflows.
Mm.
So you define your workflow in Python file and Airflow manages scheduling and running the workflow.
Yep.
So orchestrate Databricks jobs with Apache Airflow. So this is possible. That's what I was saying. I've seen that Airflow is possible, but I
Oh,
haven't checked up on if ADF is also possible. But yeah, with the APIs, yes, you can.
we can directly do it. Yep.
So this was like, based on again the use cases, right? If somebody already have their
Correct.
Airflow built and all the jobs and everything is running, they don't want to have it at two different places to manage. So they just can still create a Databricks workflow and orchestrate it from Airflow or Databricks jobs, basically, not workflows. Or they can just create the workflows and run it through API externally. Different options, whatever is best for the use case.
Yep. Makes sense.
Okay. Okay, let's come back. So this is how so normally you go and create your job and the workflows. So if you come here, so you have your sample job that we created, and then trigger is scheduled. So basically, this is where yesterday we were trying to see how would you schedule, right? So if you go here, schedules and triggers, there will be trigger type. Okay. So what you can do is you can do a scheduling of your workflow where you can give your cron syntax here. You want to do every day, hour, week, right? Or you can do advanced. You can day, minute, hour, day, week, month, and then time start, time zone. You can also just put your cron syntax if you want to, if you are aware of Unix cron syntax. So basically in the backend, it will anyway convert to cron job only, all of the syntax to run. So you can do this. If it is like scheduled, then you can go and do your every day. Okay. Or you have file arrival. Okay. So it's basically like file arrival triggers monitor cloud storage path. 10,000 files for new files. These paths are either Unity catalog volumes or external locations managed through Unity catalog. So this is where we are talking about the Unity catalog. So Unity catalog is basically when you create a new workspace, it is Unity catalog enabled. So it has the data governance built on the using the Unity catalog. I have shown the volumes, right? So if the file is coming into that volume, it can automatically monitor and trigger your job whenever there is a new file in that volume. Or you have created an external location. Say, for example, I was talking about I'm monitoring the S3, reading the S3 files from the S3 Amazon, right? So if I monitor, put a daemon job or whatever, like which is continuously polling and looking at that folder, whenever there is a new file there, it can trigger this workflow. So that is also possible. So you have to give your location here. Either it is a storage location, external location, or a Unity catalog volume path. So that options. Minimum time between triggers in seconds. How much minimum time? Wait after last change. So when you want to actually trigger this thing. So continuous is again basically it will not look for it's more or less like that, but it will not wait for a file to arrive or whatever. It will continuously poll on some trigger and then keep triggering the workflow. Okay. In this task, dependencies and retry policy are not allowed for continuous jobs. So you cannot have dependencies, when you have a continuous job. I don't know, without dependencies, how can you just trigger? But I think basically it again overlaps with so many other options we have, right? If it is a continuous, you can actually do it in a DLT pipeline, because that is also a continuous pipeline, right? You can have a continuous option there. You don't want to again create a workflow, put your DLT inside the workflow and make that continuous, right? So that's why it's like not preferred here. So mostly if you have a workflow, it will be definitely most likely be scheduled. Or in some cases, file arrival is also a good use case, mostly used use case, because you have written something, the files are coming to some location. You don't want to process, say, every 1 hour or every 2 hours. You don't know when the file comes in, and it might be small files that are coming in, and you want as and when the files arrive, you want to process it. So in that case, you can put file arrival. But if it is like only one source, right? And scheduled is the mostly used, like bad jobs, that you are scheduling your bad jobs to run every 1 hour or every morning, evening, or daily ones. So different use cases that you can have in this trigger. Okay. Compute clusters, you can give, configure, and attach the cluster to this particular workflow. So basically, whenever you run this workflow, it will use this job cluster. So if it is persistent, it will use, or if it is not, it will bring up. If it is a job cluster, it is a job cluster. So it will bring up the job cluster, run the job, and then it'll stop the cluster. So basically, your resources are not idle. It will just spin up a new cluster, run the job, and then stop it. For development purposes, other things, we use all purpose clusters, right? So this is one of the topics that you also have to talk about. What are the different types of clusters and what you should use? Job cluster, all purpose cluster, or serverless, whatever it is. You can have a serverless starter warehouse. This is for the SQL to run. So you can also use same job cluster also to run the same. So you can use whatever configuration you need for the job cluster to run this particular workflow. So if there is a different workflow which has, for example, processing huge volumes, so you might spin up a different cluster, bigger cluster to process that. Okay. So you can pass your job parameters like file paths or environment variables or whatever those configurations, you can send it in a key value pair here, and then you can read these in the notebooks. One second. Okay, so you can give the job parameters here. So you can give environment, what environment it is running, dev or whatever. And based on dev, you can do some, if it is production, you can do different things that you want to do, so that you can provide at the workflow level. And then for each environment, you can change this value when you migrate to higher environments. Notifications you can set up. Basically, when a job fails, definitely you need a notification, right? So you can send emails. You can do email address here, and then you want to send at what stage you want to send the email. When the workflow starts, when if it is successful, when it is failure, it is duration warning. So something like this. Okay. So this is the so all of these, right? You can say modify notifications. If you have skipped some of the runs, you don't want notifications, or if you have cancelled, you can add, or you can add multiple notifications if you want. Okay. It can go to email. You can send notification to Teams, pager, Slack, webhook. So when the job fails, it can even send to a Slack channel like this. You can configure a Slack channel and then send notification to the Slack channel, or Microsoft Teams, webhook, email. So these are the different options that you can set up your notifications. Duration thresholds. For example, this basically, again, the workflow is running for more than 2 hours, for more than 1 hour. For some reason, it is stuck. So we would like to know that this job is stuck. You have to take some action on this. So when do you want to send a warning? When you want to send a timeout, right? And then you can say save and edit notifications for those thresholds. Permissions, advanced settings, queue, maximum concurrent runs. Maximum concurrent runs is like if one instance is running, So let's say you have scheduled the job to run every 30 minutes, and at 10 o'clock it has started, and at 10:30 the job is still running, but 10:30 you need to start another run, right? So if you allow maximum concurrent runs to 2, then there will be another instance that will trigger if there is no conflict you see in the data that they are processing. But if you don't want to run a new job when the old one is still running, then you will just set up maximum concurrent runs to 1, and then you put it in the queue, the next one. So once that is completed, then the next one will trigger. Okay, so that's all we have about the complete about details. You can also link to Git repository URLs, credentials. If you want to read something from the Git library, you can also add those settings here. If you want to pull the Git library in if you are referring in any of the task. So that's about the workflows, as you have seen, right? So this one workflow here. This is scheduled. I haven't run anything, so that's fine. It didn't run. It might fail because we have added all different things in there. And yeah, once you go run this, you can see all the previous runs, recent runs, and what is the status. You can trigger the run from here. Ad hoc run if you want to run right now, just one part of one instance. Ad hoc run for some reason between the schedules. If you want to update something, you can go and run it manually from here. Okay. Any questions? Guys, Naina, Manideep, Raju, Varsha, any questions?
No, Harun.
Okay. So, yeah.
No, Harun.
Okay.
Harun, I have a question.
Yeah, Vamshi. Go ahead.
So let's say you're reading from a Kafka topic, right?
Mhm.
Do you also um, put that as a job, as a continuous job? Because even though it might have a start time, it won't have an end time.
Yes.
Right? So in those cases, like how does that fit into this job scheduling paradigm?
So it is a continuous, right? If you
Right.
put continuous,
Yes, because it's continuously listening to a
yeah,
stream.
once you start continuous, it won't stop unless you manually stop that.
Okay, okay. So
Yeah.
is that a kind of a job, or is that also says, oh, I have a bad job, but the source is a
No,
kind
it's,
of stream.
it's a job itself. There is nothing like a bad job or a streaming job. It's just how it processes, right? So in the notebook, in the code, you use streaming, then
I,
you define that as your streaming job, not a bad job. If you don't use, if you're not reading from a stream, if you don't just say read, not read stream, then it is a bad job, right? So
yeah,
even if it is a bad job, say, and you schedule it every 1 minute, it is almost like your um, continuous job, but it kind of starts and stops.
correct.
But if you put streaming job and then you trigger continuous, once it starts, then it keeps running. There is no stop to that until
That-
you manually stop it. So that's the difference between two.
it's good. That way it's more unified. You know, the lines between batch and stream is blurred at that point, which is good.
Yeah, so streaming itself, they define streaming is nothing but micro batch, right? So streaming is a, a typical, is a special instance of a batch job, which is running at very frequent intervals, basically. It can be microseconds, milliseconds, but it still is a batch at that level. So remember when we said there is a trigger interval. So you can set the trigger interval even for the streaming. Though the job is continuously running, it's more or less again goes back to the same concept. You have only two concepts, either a cron or a daemon, right? So cron will look at what time it has to trigger. It's a batch. A daemon continuously loops. But when does it loop? Again, it has to know whether it has to go back and check for each 1 second, a millisecond, or whatever, or a minute. So basically, again, the daemon is also a special instance, special case of your cron, right? The same concept, you come here. The batch job is triggered when you want to schedule, when it runs and stops. So you put in a schedule. Every time you put every 1 hour or every 30 minutes, it will start, it will run. So that's a batch job. As and when, as we go, keep reducing the interval for the job to trigger, it moves closer to your real-time integration. So real-time streaming use case. So as you move very closer to say, I want to trigger every 1 second or every millisecond, that's when it's more like a streaming job. Now, instead of doing the same batch job, scheduling it at 1 second, millisecond, you have a streaming job that is already continuously running. The environment, the memory, everything is open. It's kind of on the job. It's ready every time. And then it goes back and gets the data, processes, and then again goes back and gets the data and process. So what's happening at the deep lowest level is again a batch. It's a micro batch. So that batch is so small, you feel it is a continuous integration, real time. It's actually never real time. It's near real time. That's what you call, right? So if you go closer to closer, like 1 second, 1 millisecond, or say 100 milliseconds, whatever. So by the time you take the data, you process it, there is again new data, you take it, process it, then again new data. So it's like continuous. That is what you see it like real time, near real time integration processing. But if you just, even in the streaming, if you just put trigger interval to say 30 minutes, what happens? You would feel it as like a batch. For 30 minutes the job is running, it will not do anything, because until 30 minutes it cannot go and get the source data. That's your trigger interval that you have set, right? So it's like both, same use case, you can use both ways. Yeah. Okay. So this is the so workflows. So when you look at delta live tables again, we were talking about. So these are also basically same workflows. So you see here jobs. This is a workflow, and delta live table, when you create itself, is a workflow. It is automatically orchestrated. So these are like the tasks that we did. But what happened here is, since we associated a notebook with that, it has done its own, it has reviewed the code, and it has built its own dependency and its own sequence to run those tasks on those tables, live tables in the DLT. So it's also a special case of workflow that it has automatically built. So here we have manually built and put dependencies ourselves in the workflows. In the Delta live table, since we have declared live tables in the notebook, as soon as we create a Delta live table and attach the notebook, it will build the dependency graph or the lineage for us. And we have also seen yesterday, like you also have all the settings of the DLT also. You can do same triggered and continuous, just like your workflow that we were doing right now. Here also you can do triggered and continuous. So even if it is again a live table, we talk about getting live updates, processing live. As soon as you put triggered mode, there is no live. Only if you run, when you manually run it, it will process end to end, refresh and stop. Only when you go to continuous, then it will continuously poll and run the data refresh as and when the new data arrives at source. So same kind of options available here. Same, you can do compute, you can do destination is fine. So you can add notifications here as well, emails on success, failure, fatal failure, on flow, emails comma separated who you want to send. Here you can do that. So advanced configuration, you can send key value pairs here. You can read it in the refer it in the DLTs. I don't know what is this version of the delta live tables runtime used. Okay, current. So if you have multiple versions, which version, if you want to run an older version or the current version. And then this is the worker and types that uses to run the configuration, the cluster compute. Here the workers with the auto scaling. You can use photon acceleration as well. So photon acceleration is Apache for reducing your total cost per workload. It's basically a new engine, which is all of these are written in Scala and Java, the runtimes, but this Photon engine is written in C++. So it is a bit faster than the other engines, and you can choose to use that to accelerate your processing time workloads. Basically, it is at this SQL execution engine that you use. So you can choose to use photon acceleration, which is built in C++. So that's kind of a premium product. That's add-on kind of a thing that you can use to accelerate. But what Databricks says is that it doesn't matter even if you use, it's basically DBUs, how it is charged, right? So if you see here, 1.5 dbu per hour. So Databricks, how it charges for running your jobs is, it's called DBUs, Databricks units. So what this is saying is if you use this setting, okay, and if you run this job for 1 hour, they will charge you 1.5 dBUs. So how much 1.5 dBU cost in dollars, that I don't know exactly, but that's pricing, right? Basically the pricing might vary. It may have discounts. It may have depend on the enterprise size of the company and how you negotiate and all of that. But if you say you can get a discount on what is the price for each dBU price. So if you say $1 for each dBU, in that case, if you run this for 1 hour, you will be charged $1.5, something like that. Okay. So if you go to photon acceleration, the dBUs might be high. I don't know if it will reflect here. Yeah, see here. The moment you enable photon, it went up to 3.75 dBUs per hour. So which means you get charged more for using the photon engine. So make sure whatever you are running in your local machine, make sure you disable this, even if it has enabled by default. Make sure you check this and disable this on your account. So you don't need to do this. We are not doing production loads, heavy volume loads. Okay, so because it is like almost 3 times more than twice.
Does that also mean that it is 3 times faster in processing the data?
Yeah, there are a lot of the published, that's what they say. Databricks photon acceleration, if you see photon engine. So this is what they say, relative speed to Databricks 2.1.
They're like twice, almost. But they're charging thrice, but you're getting the benefit. So in the end, it's not worth it yet.
Yeah, yeah. No, see, this is Databricks DBR version. See, there's a 7x, 8x here.
Photon powered is 8x over there.
Yeah.
What's the 3x? 2x. Okay, that's fine. That's cool. I mean,
Relative speed up to DBR 2.1. So as we go Databricks version, photon powered it.
okay.
It's 8x.
Depends on budget, it's like.
Yeah. They should be, customers have observed here, right? 3x to 8x speed ups compared to the latest DBR versions. So new native vectorized engine entirely written in C++.
So slowly, actually, a lot of companies are moving away from Scala. Even Confluent, Kafka, and everybody, they are saying, okay, don't, get away from Scala, start using Java. But in some cases like this, they're even getting away from Java, right? They're going to native
Yeah, from
language.
Java, there were people moving to Scala. Now, so even that's what we talked about initial days of Databricks. Yesterday, Srini was also showing, right? So we did some earlier trainings on Scala, most of it using Scala as a language. But later on, Python caught up, got more attention than Scala because of the community and adoption and resources, all of those. So Python became the de facto choice for all the data processing, because Python libraries were already compatible or being used on the machine learning and AI deep learning libraries were all available and compatible with that than Scala. So initially, when Databricks was releasing any of these functionality, it was first being released for Scala. And then Scala is like, because Spark is actually written in Scala, right? And Scala is again on Java. So Scala, whatever you write, it gets converted to your JVM code to run. So whatever they were releasing, it was first access native to Scala. Then they were releasing to Python, then R and Java and other things. But Java became less and less relevant. And Scala and Python were there for some time. And then like slowly Python took over because Python is widely being used, not just for here Spark data engineering, but for all use cases for machine learning or for deep learning. Now, since Databricks has become data intelligence platform where everything runs on the same platform using data engineering, ML, AI, everything. So they wanted to have a common language as well that would fit across. So now Python became more relevant, and now they're talking about Rust, right? So don't know how Rust is picking up actually. Even we are doing some experiments on Rust learning. We have started some what you call boot camp for kids on Python and Rust next week for some kids. Boot camp from iGebra. So we are running that boot camp for on Python and Rust for the kids. So yeah, after Python, I think the next one to look at is Rust, because some of the Microsoft and other big organizations, they are rewriting some of their libraries in Rust from their native other languages, Java and other Python languages. They're rewriting some of those platform codes or low-level code in Rust from C++ and
I have one question you came up before, but I forgot to ask.
Mhm.
So you showed the DLT, right, which is basically another directed DAG graph,
Mhm.
the thing that's derived automatically derived from notebooks, right? So question is, when you have the Airflow, Apache Airflow, one mechanism of doing the same thing, why would anybody choose DLT versus Apache workflow? So Airflow, right? Yeah. So in what cases would one would prefer Apache Airflow versus DLT?
Okay, so these see, Apache Airflow is just the orchestration tool, right? It's just workflow tool. DLT is processing. These are two different from the functionality perspective. These two do different things. DLT can be actually part of your uh, Airflow orchestration, just like I was showing here. Uh, where is this? So even if you are orchestrating the jobs using the uh, Airflow, you can have your DLT pipeline as part of your orchestration.
So are these the jobs that you are showing
Here,
these things? These
task
are
4, your task 4,
yeah.
within this task 4, you are running the entire DLT pipeline here, right? So when you do task 1, task 2, or when task 2 is complete, it's just a query. It will just check the query saying that, whether those tables are there. If it is not there, drop it, or if it is there, whatever. When then is successful, it will trigger the DLT pipeline. So when you see in the DLT pipeline, there is a setting called trigger, right? Triggered mode. So it will trigger the Delta pipeline in the triggered mode. The Delta pipeline will start, do all of its job, refreshing tables, all of it, and then complete. The task dependency is not same as your data lineage in the DLT. What DLT does internally is it will automatically see what tables are dependent on which tables, how the final flow is happening within the tables. Based on that, it will build the lineage. That's a data lineage, right? So
Mm.
it says that this aggregation table is being built from these two tables. These two tables are dependent because we are reading from the source and then doing some transformation and filtering. So it will go back and connect to that table. So whatever you see in the DLT is a data lineage, how the data is flowing, how the tables are being built, and what tables they are dependent on. When you take any table, you can see from where the data is coming from into this table. So that is what DLT does. Now you don't have any control over that. It is like once you do your DLT notebook, based on what you have written the code, it will show the lineage. Whereas the workflow, you can choose to have what your dependencies are. Like I said, you can also see here, I don't want to have all succeeded before I run this. I can say if even at least one succeed, then you go and run the next one. So these kind of options are available to me when I do the workflow here, job, dependencies in the job.
Right. So how when you so even though you pictorially put these things together,
Mhm.
this will generate a code behind the scenes, correct?
Yes,
In JSON or something.
yes,
Yesterday you showed us. That's what can go into the Git repositories and all that.
yes. Yeah, that goes into the Git repositories. There should be somewhere. Yeah, that is where it goes. You use it to migrate and all of that.
Yeah.
Migrate to higher environments, or when you do an API call. So it uses that JSON file to orchestrate that job. It's
Okay.
basically, yeah, even the representation here is doing based on the JSON file it created. It will read and display that,
Okay.
how, put the dependencies and all of that. Somewhere it will say, uh,
I guess maybe you have to come up and click it outside, maybe outside of the in the gray box, and then it will show.
okay, I'm already.
So, Hari, one more thing. So this is the past runs, right? It says it ran for 7 minutes and all that.
Yeah,
Do you know what task processed, how many records, how many failed, and all that?
yeah. Let's see here. You can see timeline, and it will show what time it has run, task run details, what is the path data sets it has taken, modifications.
The size, no, no, what's not size, right? So like I want to know, okay, task one processed 200,000 records and
Yeah,
task
this is the task
two,
one, right? So this is task one.
yeah,
It's giving all your details here. How many records it processed, like it was showing in the DLT pipeline. Maybe you can put that count or something, but it is clearly showing here. See, yeah, we have put display, you have loans count. So it is showing the display here. In that particular run, it processed 148K. This is the task one run, right? So this is the run ID. So you can go to any run ID and see its details, open the notebook and see its run details.
basically we have to put that display statement there.
Yeah, they have to. It's not like in the DLT pipeline. So it's basically, see, any job you put, any job you run, you always try to log, right? Records processed, uh, which at which function you have executed, how many records it has processed, start time, end time, all of that you write in anything, right? So basically, it's the same thing.
And I
Whatever you want
totally,
to log, you can add those statements there.
no, I totally don't agree with that philosophy because when you're talking about a system that actually is inherently a job runner, it should inherently do things for you for free. But
Yeah,
that's okay.
that in DLT it's doing, right? In DLT it's doing because it has complete control over it. It knows that it is on working on the tables. So you actually get to see all the um, statistics of how many records processed, how many records failed, which condition it failed, uh,
Okay.
right?
So that's what I'm saying. See,
Yeah,
if
all of that.
let's see one of the executions, previous executions.
Yeah, see here it says completed 7 seconds, processed 94K. If you go here, if you go to data quality, we went through this. See, it says written 100%, dropped 0% with the count. And then if you come here, written 100%, dropped 0%. It will also tell you which condition, how many failed by percent, by records, because these are the two business rules that you have written to fail or to allow when this condition fails. So it will give you statistics of how many records failed, how many records dropped, everything it will show here for each one.
No. Can
Yeah.
you click on the schema ones over there by the data quality? There, there, yeah, over there. Can you click on schema ones? Schema on the top,
Oh,
top to the. Yeah.
oh, this is just the table schema, baby names.
No, no, but still I wanted to see
Yeah,
like.
sure. Yeah. It's about this table,
Uh,
but this is, I don't know what the flow ID it means. At
yeah,
some
yeah, that's what I'm looking for. So looks like using DLT is more productive in nature because you really don't have to bother about, oh, did I write this display statement and all that? Because, I mean, I'm more
yeah,
interested
but
in
see, if you
how the,
actually look at it, even this, it is tracking because you have written these conditions. Okay.
oh, that's so.
Obviously, yeah, we are not printing that how many failed, that it is doing automatically. Uh, but we have written the conditions, what conditions we want to check. So it is tracking all those conditions, how many it passed, how many it failed. Yes, that functionality is available on DLT.
I see. No, I'm fine, right? Through programmatically, if I declare some conditions and all that,
Mhm.
and inherently pulls those and puts as a high level stats, that's great, right? Because
Yep.
that's intelligence is there.
Yeah, absolutely.
Yes, I have to explicitly say,
There is also called data profiling. So basically, this comes all under the data profile. There is a data profiling also available.
hmm,
You do for each table in the data lineage. Uh, there is also data profiling. Basically, it says, for example, if you go here, it will show you year of birth, right? Integer. It will show you how many have distinct values, or how many have zero values, how many have null values. All of those statistics is also available. I have to check exactly where it is, but there are two aspects of it. One is data quality and one is data profiling. So both of them are available. It's called Lakehouse monitoring. So once you have that monitoring enabled, it will monitor all the tables that you are processing in the lineage. Just like this, it will build the lineage for the pipeline, and it will also give you data profiling for each table. So probably we can check that. Um, yeah, so this is actually at the uh, notebook level where you have data profile. It says available through the dbutils API, data summarize df command that you can use.
that is good. That's good enough. That's all I wanted to know.
Yeah,
To what extent am I getting metrics for free? That's all my question is. So
yeah.
looks like, using
Have
the
a count. You have
with
missing 0%. You mean standard def zeros. How many zeros are there in the data set? What is the minimum value? What is maximum value? Median? What is the custom? Double depth? So all of these features are enabled on to do the data profiling on the data frame.
oh, oh, oh.
Yeah, I think we are okay. So that wraps up the workflows. I think we have done very detailed of all the options available and building the workflows. So you can guys can go ahead and build whatever it is. So let's come back here and see where we are with. So yeah, we wrapped up the scheduling workflows and we wrapped up the Delta live tables with use cases. So we are almost here. So there's something that we want to talk about: Hive Metastore, Unity Catalog, DB SQL. So some topics. So I will kickstart with the Metastore and Databricks Unity Catalog now. We'll talk about it in about 5 minutes. So after that, these two. So basically preparing for the certification and practice demos. So my idea is for you guys, as I said, uh, pick up in any of these topics and then do a 20 minutes talk and presentation or a use case. These topics or, as I said, anything related to data engineering or business use case or architecture, whatever it is you want to present, but we want to do that starting next week. So next week, if you have any questions, anybody we want to talk about, we'll talk. Otherwise, we'll focus on the certification and the demos. And if there is something left from here, we'll cover that. Okay. So you want to talk about these. So there are like, what is this? I have some, yeah, references, right? These can be topics that you want to pick up and talk about, or build a notebook working use case that you want to demo using these, or talk about any of the topics. But basically, we want to cover all of these starting next week. So how do you want to do it? Do you want me to? I want just you guys to sign up. Let me know. Not right now, maybe offline. So what topics you want to take up and present in the next session, and then we can schedule that talk about it. And I will talk about certification, what we want to do for the certification. It's basically the review again. If you talk about all of these topics, you will be good for certification thing. Okay. Okay. So give me 5 minutes break. I will come back and then we will talk a little about Hive Metastore and the Unity catalog, what it is, how important it is for the Databricks product suite. Okay, just give me just 3 minutes washroom break. I'll be back. Okay, so welcome back. We wanted to, okay, next we want to talk about the Hive Metastore and the Unity catalog. Okay, so basically when we were already, we are using all of this for a long time now, for a few weeks. What we have observed here is, so if you go to our community edition, to log in, give me 1 second. Um, One more thing, see, once I wanted to show you the Databricks job that we have just put notification, somehow it got through. So I've been subscribed to Azure. I put this email ID, my email. So it gave me that you're subscribed to notifications for that job, sample job. I don't know if it'll take me to the job directly from here. SSO, if I'm able to log in. So from the email, it will take me to the job directly and job run details and everything here. So our notifications thing is also working, right? So you're able to see that as well. Okay. So we were going here. So when we look at the workspace here, and if we go to catalog, okay, cluster is unavailable. Okay, I have to start the cluster anyways, but I think that's fine. So here, if you see, you get something called Hive Metastore. Okay. Let me see if I go here. See, there is here legacy. In legacy, it says Hive Metastore. And here, all of these catalogs that I have created, right? So this is my workspace. I call it UC workspace. So if I go to the another workspace that I have created earlier, I don't know how by some default, I only have Hive Metastore here, legacy. Okay, I don't have any other catalogs here. So basically what Hive Metastore does is all your tables, all your jobs, everything you are doing, there is some place it has to store the information about metadata, right? So if I've created a table, somewhere it has to store, I mean, all the databases does that. It's called metadata, data about the data. So what is the table name? What are the columns? What is the schema? Which catalog, which schema it belongs to, right? So all of the data, how many, so if you've created a job, you have created a workflow, you have created a, DLT pipeline, you've created a dependency, a trigger, schedule, everything, it has to store somewhere. because how would it bring up and show you the graph and everything, right? So all that storage happens in a meta store. So every application, every database or whatever tool has its own system database you call, or a meta store that it has, where it will store the data about all your objects basically. Now, when Databricks started, it started with having the Hive meta store as its system database or a meta store. So it was storing everything, and by default, all the objects you were creating were also going, the databases and schema were also going into the Hive meta store. Now, what happened later was when they created Unity Catalog, data governance was not possible with Hive Metastore. So they designed the data governance with the Unity Catalog. So Unity Catalog, once it came in, like we have seen in this workspace, it is UC enabled. I mean, going forward, all of them are by default UC enabled. Is this Unity Catalog enabled? So here you will still have your legacy Hive Metastore, but you can create your own catalogs. Okay, here. Now what it does is it helps in getting your data governance. Basically, who's accessing what permissions I can give to which group, how I can segregate my catalogs into different um, my catalogs into different, based on different departments or different environments. All of that is possible using the Unity catalog. So if I go here and show you basically what data governance is, how it is like. So you have different roles, right? You have data analyst, data engineer, ML engineer, and applications. So they are accessing data from data lake, data warehouse, ML models, and BI dashboards. Now, this is the roles and these are the different teams. So data governance team, the question is how to secure these assets, all of these assets. Who is accessing these assets and how? So everybody is accessing these assets, but does a data analyst need ML model, right? Or an ML engineer need a BI dashboard? So how do we define all of that? If we give access for everything to everybody, you can't track who's doing what, right? So that's the data and AI governance, how it is like. Are we meeting the regulatory compliance? So there are the compliance that not everybody should see the data. There is some PII data, personal identification information data. There are some government regulatory information that that you need to follow. Not everybody should have access to that and all of that. So so these are like, what are the downside, right? Fragmented view of data and AI, disjoint tools, incomplete monitoring, lack of cross-platform data sharing, and all of that. Downside, what it is. How Databricks has come up with a solution for that is like they have a central layer called Databricks Unity Catalog, one governance model for everything, structured, unstructured data, and AI. Basically, so Unity Catalog will govern all your objects, basically, whether it is a catalog, workflows, compute, SQL, queries, everything, job runs, ingestion, even ML. So playground, experiments, features, models, serving, everything is now governed by Unity Catalog. At one place, you can provide access and manage to all the objects that we have here. Okay, so that is the Unity Catalog that has come up with. External compute, so open interfaces, how you read and what kind of access they need and all of that. So what does Unity Catalog enabling help us? One of the things that we have already done is lineage. So we have seen like how tables it can show you the lineage from in DLT. You have seen how the tables have the lineage, but even without DLT also, if you run a notebook, if you enable monitoring, you can see the data lineage, how it is flowing for these tables. You can do access controls for all of these, auditing, and data sharing. So data sharing, we have said, like when we talked about Databricks Delta, there is something called delta sharing. It's again is a data sharing where you can share your data from your delta tables to outside world directly. Okay. You don't need to have any connection or APIs and whatever it is. You can directly share the data from your Unity catalog tables to a third party, and then manage that security and what data you want to share, what type of data, what is the access that they can get, everything. So that is also possible through Unity catalog. It's called delta sharing and Databricks delta tables. So unique capabilities, before coming here, we see go here, all your metadata in one place. Okay. Without Unity catalog, if you have the main difference here, if you see, if I create a workspace, so there are multiple workspaces you create, right? So here I have created two workspaces. There is a one UC workspace, and then there is one Starbricks demo workspace. Now the difference is, without the Unity catalog, if you just use Hive Metastore, I have to do user management for this workspace separately and for this workspace separately. Metastore, metadata is stored for each workspace separately. Access controls, cluster, warehouse, everything is based on one workspace. So the other workspace cannot have the visibility into this. But with Unity catalog, the user management and metastore will go into central repository. So there will be one Unity catalog per each region you enable. And then all the user management across all workspaces will be managed at UC level. And the metastore is at the UC level, the top. So here it is fragmented. For each workspace, you have to do separately. Here it is centralized using Unity catalog. Foreign databases, access controls, everything. And then when you create multiple workspaces, so clusters and warehouses are at the workspace level, but user management and metastore are at the Unity catalog level. So this is also one of the certification questions. What benefits you get using Unity catalog with respect to workspaces. So user management and metastore management goes at Unity catalog, and you can have only one Unity catalog for each region that if your organization has subscriptions across multiple regions. So each region you can have one Unity catalog. Of course, you can also do cross-region sharing and all of that. But at basic level, this is what it is. Okay. Now, how you manage this governed namespaces across files and database sources? If you have a Unity catalog, we have seen, can have a catalog and schema. Under that, you have volumes, models, functions, tables, etc. Right? So this is what we are doing here. You have a Unity catalog. You have a UC workspace. This is a catalog, and this is the schema. And in this, you can have tables, volumes, models, functions. You can have managed or external tables. You can have views. You can have everything under this here. Okay. If it is in the legacy, you have default database. You cannot create a database. Under the same database, you keep creating your customers, tables, etc. If you start the basically here, I don't have the, I cannot see that. I have to start the cluster. It will take some time, but you have only default database. If you go to catalog, and under that you create the objects in the Hive Metastore. Okay. So this is just accessing. So what you can also do, row level security and column level masking. You can create functions if you have Unity catalog. So basically row filter, right? So you can say there are questions in certification from this as well, I think for professional. If you create a function, you want to filter based on the region. You say if whoever is accessing it if he is a member of the admin group, okay, then you will get return true, which means that you get access to all data. Otherwise, you get region only to US data. So something like that. Once you use this function, so you can call this function US filter. So based on your role, it will automatically give you the data only for your region based on the US filter. Only you get to the US region. Or if it is admin, you get all data, something. This is column level masking. Say, for example, like SSN number here. You don't want to show the actual data, but you want to show only the asterisk, masked data. So then you can create a function for masking and say return, if it is admin, you return the actual SSN. If it is any other role, then you return the masked data. You will not show the actual data. So these functions you can directly use in your SQLs. Okay. So this is one of the features that is used when you are using the security thing. High level. Okay, so this is one. Managed data sources, external locations. This you can do. So this is how you do Unity catalog, catalog 1, catalog 2. Under each catalog, you will have schemas, and under that you can create your managed cloud storage. You can have external connections, credentials to S3, ADLS, or Google Cloud Storage, all of those objects. So once you have the Unity catalog, you can control which can have read-write access and which have only select only access from this. But this is important. Once you have one meta store, you can create catalogs based on your environment. So you can have a one catalog for dev, staging, prod, BU1 dev, BU1 staging, BU1 prod. Okay, guys, everybody pay attention to this, because this is very, very important, not just from Unity catalog perspective, but in general, when you are talking about any project or execution that you have done in your company, you should talk about this. Okay, you should talk about, say, this is how we created our catalogs, for dev, staging, prod, and then we created different workspaces. Okay, so what workspaces? Workspaces were based on the groups. So for example, developers. So all the developers in the team were given access to dev workspace. Okay, this is a workspace we have created. Now this workspace has access to dev and staging catalogs. If this workspace does not have access to prod, so developers automatically will not be able to access prod. Correct? Are you guys still here? Okay. Now, staging. For staging also, developers has access. So developers have access to dev and staging catalogs through these two workspaces. Developers have access. Now, testing team has access to staging and prod. But again, they can have read-only access to prod and read and write to staging workspace. So that's how you can define based on catalogs and workspaces they have access to, which workspace will have what kind of access to the catalog based on the groups. In the prod, analysts and testers, I think they would have read-only access in prod. So BU developers, BU testers, so business unit. So there is, so let's say in general. So suppose you have different business units within the organization. Okay, so for each business unit, you can create a separate dev, staging, and prod. Okay, so in my previous organization, we had like 4 units. Retail. It was a retail. So they had pharmacy, they had optical, they had gas, and then they had a different um, pharmacy, optical, gas, and say grocery, right? So data was coming from for all of these from different vendors. So how do when we were writing pipelines, the team were different. So the staging areas were different, right? And that's why we created by business unit. So the gas data should not be visible to either developers or testers on the pharmacy side. So it was segregated. So how it was segregated? Because we had defined different catalogs and workspaces and given access to those developers specific to those workspace so that they can access specific catalog tables from that. So this is all how it is done using the Metastore, Unity UC Metastore. This is anyways, how query based data sources, what happens when you run a query, send a query from here. It will first go to Unity catalog. It check the namespace, metadata, grants, what access you have, whether you have an access or not. It will write to audit log, what was done, what was requested, and all of that. Then it will go to cloud storage, assume identity federation, IAM role to access this. Return the list of path or data files that are needed. So basically, what you need to know what data you have to read, right, to get this result. So that is where, based on the Unity catalog access, you go here and get those files to this, and then there's a request from the warehouse cluster to ingest data with temporary tokens or return data and then send the result. So this is all happens when you just do a query or write to the data frame dot write or read whatever you want to do. So this is how all of the internal, what happens internally in terms of access and security stuff. Okay. Sources with file based. So this is database. Same thing here, instead of files, it will go to database and get. So everything else remains same, but here it will go to database and get things. Volumes, we know where we can put our data. There's automated lineage for all workloads. So this is one important feature. So end-to-end visibility into how data flows and consumed in your organization. Data lineage and Databricks cluster or SQL warehouse. Track lineage down to the table and column level, leverage common permission model from Unity catalog, lineage across tables, dashboards, workflows, notebooks, feature tables, files, and DLT. So all of this, you can capture the lineage. Probably next week, we will try to see if we can show, use case with some lineage. If we are able to see how we use lineage. Job compute. Configuration. Log. This is all monitoring what all queries that were run from the sample job. Okay, there should be something called monitoring. I will check on that and see if we are able to get to that. Vector search. compute for DLT. This job. Okay, that's fine. We'll check and come back to how we can do the lineage.
Harun, since you're here on the Databricks page,
Mhm.
can we really quickly just set up a few permissions on one or two tables or schemas just on Unity Catalog?
Yeah, we can do that.
Because yeah, I was playing around on this. I don't have much in my new workspace, so I was putting their permissions and
Grant.
and then we just do it on the principles. Okay.
Yeah. So we have to create first. We have
Create
to, yeah,
groups.
groups and principals and add users to that.
Yeah.
That will show up here. Then we can say which privilege I want to add
Mhm.
to all of this or all privileges,
Yeah.
something like that.
And the masking, it's done at a function level. And so how does that tie to this? Because now when we were, for example, for
Oh
the
yes, here the image. Oh, we got here. So it's at the tables, the lineage.
table. Okay.
So it shows lineage direction, downstream, upstream. Where is the definition not supported for this table? But it's not saying something not supported, but tables, notebooks, workflows. Yeah, if you go to sample job, so basically when you go to say if I want to see some issue with some table, right? So if you go to that table in the lineage, it will show where all it has been referred by and how it is being used. So table names, in which workflow it is used, in which pipelines it is used, uh, in which dashboards it is used, in which queries it is used, if there is already a query or
Just
like
like in SQL, we have that reference, the dependency thing, right? Which
yeah,
shows where all is being used. Okay.
it's a lineage graph. Yeah, see here you can see the lineage graph again. It's coming from the DLT that we did. So where all this table is being used, that lineage it will build and show you that lineage. Okay. So that is the lineage and that is the permissions that you can go here and grant. It's basically, see, any database table, it's the same concept. It's just how you do it in different tools is different, right? So even if you go to MySQL, Oracle, or whatever, you say grant permission on this table to this user, and what are all the permissions you want to give, and then there's a federated, can he access further to other users, kind of permission that you can give. On schema, you use give, usage. First, you have to have a database usage, and then you have schema usage, and then on the tables or other objects where you can have read or write kind of permission. So you have to give privileges. When you have to first give access. It says to grant use schema. So you have to first grant the use schema and the database and the catalog. Then you can give all other access to this. Okay, so that is the lineage. So we were able to showcase the lineage flow, how it works. So ETL job, ad hoc or DLT, ETL and ad hoc jobs, normal jobs would come through cluster or SQL warehouse. DLT is directly connecting to the lineage service. Then you can go table and column lineage. You can explore in the UI that we have seen how it is connected in the workflows or any other wherever it is, or external catalogs also. You can export and view that in the external catalogs. To a cluster or SQL warehouse executes data flow when any language, whether it is Python, Scala, whatever, Java, whatever you run the notebooks on this. And then lineage service analyzes logs emitted from the cluster and pulls metadata from DLT. How it builds the lineages. The service will analyze all the logs that were provided by the cluster and will build a lineage service. Assemble column and table level lineage, present to the end user graphically in Databricks. That's what we have seen right now. Built-in search and discovery is already there that we have seen. Basically, again, if you go to tables here, you can search. You can actually add tags. Okay. You can search for table, node, data, recent, whatever you can search. You can add tags to this table. There should be somewhere where you do the system quality. No, maybe you have to go to Data Explorer. Okay. No, it's coming back here. Same thing. Okay. Tables, queries, dashboards. This UI is changed, I believe. Yeah, so you can search for data assets. You can search for all tables here in the search and apply tags to data and search across tags. So each table, we can put some tags. For example, if you have customer table, right? So you can add a tag to it saying SSN. So whenever there is reference to SSN, it will pull out all the tables that have the reference to SSN column. So that you can add that function, right? You said data masking. So you can do that based on the tags. You can identify all the tables. So this is what we're talking about, discovery tags. So is it at the columns? I think, okay. That's why it was not able to show. Let's go here. See here, add tags. So here you can add a tag, key and a value, and that tag will be used. So you can add PI data, sensitive data, whatever like this. Once you have that, it will allow for discovery wherever, if you want to do in the entire system, what is all my PI data? It will give you all the tables that have your PI data. PI data means basically your personally identifiable information, your phone number, email, SSN, date of birth. These are considered, some of these attributes are considered as PII data, where it should not be visible to all of everybody in the company. So to limit that access, you kind of restrict using PII data or sensitive data like SSN or his account balance, if something like, numbers, something like that, sensitive data. So you can tag the column when you are defining your table, you would know, right? So when you're defining a table, you will know whether this column is PI data or sensitive data. So that is in the definition. So based on that, if you put tag here, you can search in the entire system. You can pull based on that tag. It will give you all the columns and tables that has that tag. And finally, this is what the delta sharing I was talking about. This is a very beautiful concept from Databricks, where you can share with your third-party vendor customer without giving them any kind of access or authentication authorizations, that set up permanent links. So what they do here is you have a Delta Lake. The other customer need not have any Databricks environment at all or Delta Lake at all. They can just have a connector and request a table. We will have a Delta sharing server. It will go back, select what are the files that is needed based on the request that you need to give it to them. So it will send you pre-signed short-lived URLs to the third party consumer, whoever he is. Pre-signed short-lived URL. So this URL will have all the authentication and the access, and they use this, and it is for a temporary period, short-lived. Now, once they take that URL and use that URL, they can directly read the Delta files that are stored in the cloud, not through any layer or application or Unity catalog or whatever it is. Once they have the URL, they can directly read the data from the underlying files of that table in the storage. So direct access. This is temporary direct access to files, the Delta format in the object store, whether it is if it is Azure, it is stored in ADLS. Google Cloud, it is stored in Google Cloud Storage, GCP, or AWS S3, wherever the Delta table is being stored. Remember, when we are doing Databricks Delta, we showed you the path where the what you call the JSON file, transaction log is written, and the actual data files are written. So you will get access to those actual data files from here, .parquet files from here. And then they can directly access the Delta files. However, all the authentication is already done, and based on that only the URLs were provided, and then they can access, and then it is again temporary. They can only access this files, read-only files. This is how under the hood, how it works. Delta table server, it has access permissions. It uses Delta sharing protocol. In the request, they give pre-signed URLs to Delta sharing client, and they have direct access to the files. The same thing, but they talks in detail about the protocol, how it authenticates, and all of that stuff. So we are at time, and that is all about the Unity catalog and what benefits you get using the Unity catalog, how you use the data discovery, data lineage, data sharing, and the whatever you have this, how you design your environments to provide proper access to various groups in the organization. So I will also upload this document. This is provided by Databricks, so it's not proper. It's open. Anybody can have access to this. I will share this document also in our uh, running document. Go through the important slides that we discussed today. Okay. With that, we wrap up our technical sessions. Then we will move on to the demos, discussions, certification, preparations, use cases, and all of that. Any questions, concerns before we wrap up the session today?
No, I'm good.
Good. Okay, Vamshi?
Very useful session today. Thank you. Thank you.
Ah, good. Okay, I know you love when you hear about some new concepts.
Yeah.
Excited, you get excited. Yes, data sharing is one of those. I think it's a new use case. Yeah, you can read more about data sharing. I'll share you that. There's something also called Delta Clean Rooms that is coming up from Databricks. Clean Rooms is also similar concept, but basically here in Delta sharing, you give access to the files to the third party. In Clean Rooms, it's like a common environment where both of them come together, share their data. There will be one moderator kind of thing. They come together, share their data, do whatever processing, and then go away, and then the room is cleaned kind of concept. I think that's still still not publicly available. I think it's still in POC, so going on. But the work is being done there, Databricks, for that concept.
Yeah.
All right, guys. Naina, Mandeep, Lahari, Varsha, Raju, are we all good?
Good, Arun.
Okay. All right. Take care then. We'll connect offline. Please ping me what topics that you want to choose for next week. We'll communicate in the group, finalize something for the next week so that you can come and talk about everybody 15-20 minutes. Okay. All right. Take care. Have a good rest of the weekend. Okay.
Thank you.
Thank you.
You're